Hello and welcome back to today's video. We are going to go through two questions from the topic of electricity from the 2005 to the 2009 past year PSLE science paper series, along with the annotation and answering techniques. So without any further ado, let's begin with the first question. Study the circuit below. Which of the bulbs B and C will remain lit up when bulb A blows? Okay, when bulb A blows, what do they mean by blows? Blows means the bulb gets fused. And how does this happen? Well, most frequently the bulb gets fused when too much current flows through the circuit, and this causes the filament of the bulb to get very hot, causing it to melt. And when this filament melts, there's a break in the circuit, because if you see, a bulb is like this. You have this, sorry for the drawing, you have this bulb with a filament inside like this. This is how a bulb would look like in a simplistic way of drawing it. And the filament overheats and it breaks apart, it melts away. So you would have this kind of a break between these two parts of the filament, because the filament melted away, so an open circuit is formed. And when an open circuit is formed, there's a break in the circuit. So since there's a break in the circuit, current will not be able to flow from the negative end, from the positive end of the battery to the negative end of the battery. If this is a circuit like this, then since there's a break at this particular point in the filament, electricity will not be able to flow from this positive end, so it will stop over here all the way to the negative end. It won't be able to flow from the positive to the negative end, so the bulb will not light up. So that is what they mean by the bulb is blown or the bulb is fused. Okay, so I have drawn a diagram over here, and this is just a replica of the given diagram. I have replaced the drawing of the simplistic drawing of a bulb with this drawing over here. So if you can, as you see, this circuit is comprises of one parallel connection and one series connection. Now where is the series connection? It's between bulbs A and B. A and B both are connected in series, in a series connection. And what is a series connection? It's a type of connection where you have only one path for electricity to flow through. So if you look at the orange arrows, you have electrical current flowing from the positive end of the battery in this direction of the arrow, from L to M, M to N, N to the filament inside the bulb. And then since this filament is intact, there's no break, there's no open circuit formed, the current continues to flow from bulb A into bulb B, where again there's no opening, there's no break in the filament. And then from bulb B, it flows out of the bulb, the current flows out of the bulb to point Q, and then it returns to R, then finally at S. So since since the bulbs A and B are intact, as in to say that they are not fused or they're not blown, a closed circuit is formed. So this allows A and B both to light up. And if you see, bulb C is connected in a parallel connection to bulbs A and B. So and the thing about parallel connections is that the same amount of electricity flows through each path. So the amount of electricity flowing from point N to bulbs A and B would be the same as the amount of electricity flowing from point O into bulb C. So yeah, electricity would flow from point N to O, then from O inside the bulb. Now again, the bulb is intact. There is no break in the filament, so the current will continue to flow from flow from the out of the bulb to point P, where it then eventually returns to the negative end of the battery at S. So this is how the closed circuit would be for this setup. However, it is given that bulb A is blown. So over here we have bulb A, which unfortunately, due to most probably overheating, which I just explained previously, is blown. So there's a break in the circuit because this filament has melted away. So now let's redraw the path of the current. First, it would flow from L to M, and then from N to N. And then from N it would flow into the bulb like this. However, there's a break in the filament over here. So electricity will not be able to flow from this end of the filament to this end of the filament. And as I explained before, a break in the filament means an open circuit is formed, which means that electricity will not be able to flow from this point of the filament to the remaining part of the circuit in the first series in the first parallel connection. So then, since electrical current cannot flow from this point onwards all the way like this through bulb B and back to the battery, since this flow is not possible due to the open circuit formed over here, bulb B will remain unlit, because these three dots, it means because, so I'm using it for to save time. So it remains unlit because an open circuit is formed. Yeah, don't worry, I have created a written explanation in the following slide, so you can pause the video over there and have a look at it. And now let's look at the second parallel connection, which is basically bulb C. We have current flowing from L to M, is this orange arrow, and from M to N, this blue arrow, and now from N to O, and then from O to bulb C. So the current would flow into bulb C through the filament and then out of the bulb like this. And then again it would flow back all the way on top, back into the negative end of the battery at S. So in the second parallel connection, a closed circuit is formed. Why? Why? Because there is no break in the filament inside bulb C, right? Bulb C is not blown. Bulb C is not fused. So there's a closed circuit formed, and the electrical current is able to flow from the negative end of the from the positive end of the battery at L to the negative end of the battery at S through bulb C. So this will cause bulb C to light up. So I hope this gets this question cleared. And now let's look at the options. B only will remain lit. Nope, this is fused. B will remain unlit based on the diagram I just drew below. So B will remain unlit. So any option which has B will be incorrect. And none is also incorrect because over here bulb C is lighting up. So option 4 is also wrong. So it means the only option left is 2, which is C. So the answer is 2. Siva wanted to find out whether liquid X is a conductor of electricity. The diagram below shows some of the apparatus found in the science room. Wire with a rubber covering, liquid X in a glass beaker. Okay, there's a keyword over here that says glass beaker and rubber covering. We have a battery, we have 2 batteries, a crocodile clip, and a lamp. Which of the following shows the most suitable setup for Siva's experiment? Okay, so in this he wants to find out if X is a conductor of electricity or not. So yes or no, conduct electricity. So to save time, I just created this notation. Does it? We need to find whether X conducts or does not conduct electricity. So that's what the tick and the cross stands for. Okay. So to identify whether a substance or any material is a conductor of electricity, there is one important thing that we must have, and that's an indicator. Right? Now it can be anything, but in this case, we have a lamp, and this lamp will serve as an indicator to test to help us identify whether X conducts or does not conduct electricity. Now, why is that so? This is because in a typical setup to find out whether X is a conductor or not, you would insert these crocodile clips into the liquid. Okay, if I draw the diagram out, you would have these batteries, this wire with rubber covering, and then you would insert it into and then you would attach it to a crocodile clip, and then you would insert it into a beaker of the substance which you want to test for. And you would have another clip over here connected to this bulb, and this is a circuit. So yeah, the liquid X is inside here. So if X is a conductor of electricity, electric current would travel from the positive end down in this direction through the bulb and through this crocodile clip into liquid X. And if X is a conductor of electricity, this current will continue to flow through the liquid like in this direction, and it would be received by this second clip over here, and then this electricity continues to travel up the circuit back to the negative end of the battery. So this forms a closed circuit if X is a conductor of electricity. So then your bulb will light up. However, let's say X is not a conductor of electricity, then an open circuit would be formed because current would not be able to travel from this clip to this clip. There would be an open circuit which is formed. So in that case, the bulb will not light up, and that helps us to identify whether X is or is not a conductor of electricity. So this should be the setup, the ideal setup for this scenario. So now let's look at our options. Option 1 and 2, we'll rule that out because there's no bulb. So 1 and 2 would be wrong. Now let's look at 3 and 4, where both of them contain a bulb. Yes, they have a bulb. Now let's look at the placement of the wires. In option 3, these clips, they are attached to the glass to the glass beaker over here. And this is why the first keyword over here, liquid X in glass beaker, this glass is really important, because we know that glass is an electrical insulator. It does not conduct electricity. So in that case, even if X happens to be an electrical conductor, but since the clips are connected to the glass beaker, an open circuit will be formed. So you can't identify, you won't be able to tell whether X, you won't be able to confirm for whether X is or is not a conductor of electricity. And in option 4, yeah, both the clips are submerged inside X. So if X is a conductor of electricity, the bulb will light up, and if X is not a conductor of electricity, then the bulb will remain unlit. So the best option in this case would be 4. So those were the 2 questions for this video. If you guys found these questions helpful, don't forget to hit the like button, and do click on the subscribe button and the bell icon to be notified whenever I post a new video. Moreover, please do help me achieve my goal of helping as many people as possible by sharing these videos to other people you know, so that even they can benefit from these. And if you happen to have any doubts or any questions, as usual, feel free to put them down in the comment section below, and I will do my best to answer them. So do stay tuned for my next video. Until then, goodbye.